Yeah, thank you guys as well. In terms of the opportunity to talk, I must admit I feel a little bit out of place because I'm not a foods guy. I'm very much a plastics guy, originally a chemist, but obviously since we have so many issues around plastics and packaging, it has interfaced so intimately with the food market. But I take the previous speaker's point about this feeling a little bit overwhelming, because if we look beyond food and we think about our plastics universe and pollution that is happening all over the world, we think about the broader impacts of climate change and our carbon footprint. We think about the fact that we're in the middle of a pandemic. I would remind people that that is a biological molecule which seems to impact our bodies as well. So let's not just concern ourselves with man-made chemicals, but it does feel really overwhelming. But this is really what drives a lot of passionate people in academia to try and make changes. And so what are those changes that we really want to try and do? Well, we are focused on sustainability and plastics in general and the systems in which they exist. So plastics to packaging experts might mean one thing, but plastics to the general public and certainly a diverse range of policy and industry stakeholders might view things differently. I will say, if you do have questions that come up after this chat, you can just get in touch either on Twitter or by email, and I'd be happy to start those conversations. So why did I bring up the public? Well, because a lot of decisions about sustainability, which is really what we're targeting, is down to the choices that individuals are making. And so an individual stakeholder is fine, but an individual who's making a decision on what beverage they want to drink and what vessel they're going to drink out of has a real consequence. And so whenever I do this in public, I get to ask people to raise their hands, but of course we're limited to Zoom right now. But if you want to make a more sustainable choice, most people, most of the general public would choose this ceramic mug on the right-hand side, because they're looking at that styrofoam cup on the left-hand side and they're saying, well, that's plastic, it must be bad. We've got demonization. But when we overlay this, not just the plastic, but how that interfaces with the rest of our energy system, we realize from an energetic standpoint, we can make, transport, use, and dispose of over 500 of those styrofoam cups for the total energetic cost of one ceramic mug. And this is because making those materials is exceptionally efficient, and the transportation of them is extremely easy because they're so light. And so when we overlay not just our challenges around plastic sustainability, but our commingling of energy challenges, we get to really a quite complex future. And so by complex future, well, this is in fact much more complex because the public doesn't necessarily understand the complexity of why these plastics are there in the first place, or in fact that these are more than one thing. So as a polymer scientist, we look at these materials in a very different way. So when we work with stakeholders, we first say, okay, whenever you're looking at that plastic system, you identify reasons why those plastics are there in the first place. And so you have to maintain the shelf life and the food safety standards that you introduced plastics for in the first place. And so if you want to have an alternative material, you have to at least meet that baseline, if not exceed it. So identify the things that you can keep doing. But of course, lots of times marketing people get a hold of these packages and do something different with them. And so why does that steak in the top left-hand corner look better? Well, it looks better actually because it's on a black background. And that's a marketing tool that might make your product easier to sell, but actually it decreases the recyclability. It changes the fate of the material itself. And so you have to avoid things within your packaging system that will prevent any potential fate, at least in terms of what the optimized fate would be to keep it in its highest value condition. But then if we look at that package, we have to recognize that the potential fates of those might change based both on the materials themselves and on societal practice. And so I can say we have a plastic tray or a maybe plastic reinforced paper tray. We've got a lamellar film that is 5 or maybe more micron thin layers of plastic. We've got adhesives and heat seals and a paper label that probably has been reinforced with some sort of a plastic, and an absorbent plastic mesh potentially underneath the meat that's soaking up the meat juice. And so when we think about the potential fate for those materials, we might say, okay, we want to get those to be reusable or recyclable. And so we could go and develop those materials to do that, but there is no way we're going to get the general public to take a plastic mesh that is soaked in meat juice, wring it out, rinse it, and put it into the recycling bin. And so we really, as scientists, as packaging experts, need to be driven by practice and not wishful thinking in terms of what we want materials to be. And of course, this extends to the rest of the plastic universe. And so what certainly in the United Kingdom, what we have seen is a conflation of different types of plastic, which are infiltrating the food supply and then changing the potential fate because of contamination. But that doesn't mean that plastics are not useful to prevent a pandemic or to control our hospital environments, because they prevent infection, they provide consistency, they do sterilization really well. And so we have to keep doing those things. But of course, if any of you have taken a home COVID test kit, you realize how much packaging is actually associated with that. And there is a lot of excess associated with that. And so removing things is really essential in all of these different environments. And then finally, we have things which are perhaps mislabeled and sort of further complicate what society's understanding of these materials are. So this is a set of wet wipes. It says on it that it's 0% plastic and 100% biodegradable. Well, 0% plastic uses an incorrect use of that word. So plastic simply means that this is a thermoplastic and it will deform. But this is a use of plastic to identify something that is coming from petroleum feedstocks. And so because this is made of polylactic acid, well, then you have a material which is being marketed as not plastic when it is in fact a plastic. And of course, because that is PLA, we understand that the biodegradation actually only happens under industrial biocomposting conditions. And so that's really not biodegradable in the way the public might think that term means, because their view of biodegradation is I can flush this down the toilet or litter it, and it is going to biodegrade wherever we see. And so we see a change in practice based on how things are marketed. And so that means we really have to be quite careful in terms of what we view as plastics and the changes that we make. And so as food packaging experts, I really urge you guys to think about that broader set of plastics that the world is interfacing with, because all of these are conflated in a waste management system. And of course, that idea of plastics being made out of polymers is even more complex when we think about the world around us. And so the demonization that happens in a grocery store doesn't get transferred over to, let's say, the demonization of textiles or PPE or electronics or footwear, or even the adhesive that is attaching this Extinction Rebellion member's hands to the London Stock Exchange. All of these are polymers. All of them are behaving in that same way. And we really need to understand the co-fate of all of those materials, not just the sustainability of a single system. And so what does a sustainable material look like? Well, we first have to recognize that sustainability in materials probably never have some sort of a perfect solution. There is certainly never a panacea which is going to work for all systems. So we have to recognize that plastics and polymers hold massive societal value. We have to recognize that many of the alternatives we might choose are going to produce more waste or in fact increase our carbon footprint. And we can't lose sight of those sustainability goals because we want to solve a plastics problem. We have to co-develop those things. We have to recognize the diversity of those and recognize that the system needs optimization for multiple potential fates. And if we look at life cycle analysis, we understand that reuse should be prioritized over mechanical recycling, which should be prioritized over biodegradation, or chemical recycling, which should be promoted over pyrolysis. But that doesn't mean that all of these different potential fates aren't important, but we have to have a move away from the demonization of plastics and not say we're going to go for zero plastics, but actually to have a system where we treat this instead of as a waste, but as a resource. And so recovering value from plastics becomes the focus, retaining things in the highest value condition. And that means we talk about a sustainable system and not a sustainable plastic. I'm just looking at my time and I think I'm going to run out. So I'm going to skip my video, but I think that what's really important here is that we use past tense terminology. So a few people today have talked about having things that are recyclable. It doesn't actually matter if something is recyclable or compostable or biodegradable if it is not recycled, composted, or biodegraded. We have to start understanding the actual fate of the materials, not their potential fate. So I'm going to skip this video, but you can see it online. It's on YouTube. And just talk about our one bin to rule them all project. And so by looking at that one bin to rule them all project, it recognizes that lots of different types of plastics are going to come into a system all at once. And right now we're using archaic methods to do this sorting, and we need to sort better because we need to sort based on value. And that allows for future systems to be developed that commingle potential reuse, mechanical recycling, chemical recycling fates in the system. You may be familiar with the Holy Grail project. This is quite similar, except it's underpinned by an open data principle, and it's very much tagging agnostic. Multiple different tags are going to be needed for these different decisions, and they have to work together. You can see some of our partners, it is very UK focused, but if you are from not in the UK and want to get involved, then please do get in touch. And of course, when we think about that idea of switching towards biodegradable systems, well, we really have to understand that the potential risks for these systems are really poorly understood. And so not only do we need to recognize that biodegradation has to exist alongside those same mechanical recycling and reuse systems, but we also have to ensure that we understand that property retention is going to be there. We have to do realistic degradation studies in the environment of release. We have to understand the ecotoxicological considerations of those degradation products, because it's not just the monomer, it's the oligomeric forms. And this has to be underpinned by life cycle assessment to ensure we don't damage our carbon targets. And so what's remarkable about this is actually many of the things that we already need are in place, but we have to ensure that that standardization takes place in order for us to actually gain value from it. Because it's easy to say, okay, we have a material reality that will work, but if we don't understand the context of the social reality and economic reality within that, then we are lost. And that economic reality is really important. And this is why we build supply chains up and then test new business models with them to ensure that this will work. And so it's quite an active process, but it's looking, let's say 5 years down the road, in what a waste management system would look like. And it's always targeting a greater retention of these plastics in their highest value condition. And so what that means is that we look at not only what decisions can be made now within a materials recycling facility or a plastics recycling facility, but also how they would change with investment. So we interface directly with policy actors here in the UK to get them to invest in certain infrastructure to unlock profitable change for remanufacturing within this country. And then we look at what tags are going to enable those decisions. And what we've already seen is that there is no single tagging solution for that. There's lots of different decisions because the values for the different stakeholders change based on the information that's in the tag itself. And so, sorry about that. And so if you want to read a little bit more about this, we have published a paper on this. It is open access, and so you can download it and read it for free. It is through that UK lens, but we really are looking at, for partners who want us to extend this conceptual framework on how you might use the data that's being gathered to other countries. And we're actively working on this right now. And so I come back to those three words. So I sit within what's called the Sustainable Materials Innovation Hub at the University of Manchester. This facility, which is one floor of this beautiful building called the Henry Royce Institute, is very much industry focused. So we sit at that academic industry interface to ensure that when innovation happens, you get to that past tense terminology. So we actively explore better ways to do recycling, better ways to do degradation, better ways to weather your materials to be able to look at ecotoxicological impacts and really enjoy having an academic group that interfaces and delivers change for industry as we go. I will say that our group is exceptionally diverse. So the three people whose project I talked about are Siobhan, who's a materials scientist, Adeyemi, who's an economist, and Torek, who is a social scientist. So that interdisciplinary within the same office and within the same lab allows us to really get much more robust decision-making when we're trying to help these industry partners. So thanks once again for the opportunity to talk to you today, and happy to take any questions in this session later on.